In section R.6, one of the things we work with are complex rational expressions. What we have is a fraction within a fraction. There are two different ways to work this. When we have a problem like the one listed up here, where we have x squared minus y squared over xy, and that's our fraction in the numerator, and then our denominator has the fraction x minus y over y, what we might like to do to work this is think of that fraction bar that we have as a division symbol. If we do that and we rewrite this, we would get x squared minus y squared over xy divided by x minus y over y. When we work with fractions and we are dividing, we know that we can change that division into multiplication, and then we have to use the reciprocal of the fraction that immediately follows the division symbol. So as we turn this division into multiplication, it would look like x squared minus y squared over xy times, and then we want the reciprocal, so we are going to have y over x minus y. Now, we know from multiplication with fractions that we can take any factor in the numerator and cancel it with any factor in the denominator. We are going to need to factor this first denominator out because that is the difference of two squares, the x squared minus y squared. So this would become x plus y and x minus y. Then we look and see, are either of those factors in the denominator? We see yes, the x minus y is right there, so I can cancel that out since one's in the numerator and the other's in the denominator. And we look to see, do we have any other common factors? We see a y right here up in that numerator and a y in this denominator. That both of those will cancel out to also give us ones. Then we want to look to see, what do we have left? There is nothing else to cancel. We only have an x right here, but we do not have an x by itself up in the numerator as a factor. So we will take x plus y times 1, which gives us x plus y. In the denominator, we would take x times 1, which would give us an x. So we come up with a simplified complex rational expression that would be x plus y over x. Now, let's try another one. This was the first way to try them. If instead we have a problem that looks like this, so this one is 5 plus 4 over x for our numerator, and our denominator is 1 over x squared, and then a minus 2. Now, we could work this in the same way as we did the last one, but we would have to do more work to get them to be a single fraction over a single fraction. So instead, let's look at all of this fraction and say, what would be the common denominators of the fractions that we see? Well, we've got an x and an x squared, so our lowest common denominator would be x squared. What we are going to do then is multiply both the numerator and the denominator by x squared, and when I do this, I should clear those fractions out of both the numerator and denominator. So this is going to look like this. We're going to take 5 times the x squared plus 4 over x times the x squared, but for ease of canceling, I'm going to make that one an x squared over 1. Then we come down to our denominator, and we have 1 over x squared. And once again, we're going to take that times x squared, but I'm going to make that an x squared over 1 again for ease in canceling. Then we have minus 2, and we are also going to take that times x squared. What we've done in each of these cases is taken each of the terms times our lowest common denominator, which was x squared. Now, when we go through to work this, we're going to take our 5 times our x squared, get a 5x squared. Then, when we look at the 4 over x times the x squared over 1, we are expecting to be able to get rid of this x in the denominator, which we can, and it will cancel out with that x squared, leaving just an x up there. So we are left with 4x over 1, which would be 4x. Our purpose here was to get rid of that x that we had in the denominator, and this worked. So then we come down to the denominator of our complex fraction, and we see that this x squared is going to cancel, leaving 1's in both the numerator and the denominator. So right there we're going to have a 1. Then we come over and multiply the 2 times the x squared and get a minus 2x squared. We have used just a little different method. We've come up with that lowest common denominator and multiplied through, and this has nicely gotten rid of our fractions within our fractions. And we look at this and see that certainly our denominator cannot factor using just integers, and our numerator, we could factor out an x, but that doesn't help us as far as doing any extra simplification. So we have our reduced complex fraction.